We are going to see this example, simple example, using the uh, block diagram method. How do we actually go about doing the simulation when we start from scratch, basically? So we're gonna, in general, I can tell you that what we need to do is to write the differential equations of the system and then transform those differential equations into a graphical form in Simulink. So based on that, I do the development on this. So here we go, we say, okay, this is the this is the mass in here, and around the mass we are going to put the forces that we see that we need in here. So this is the free body diagram, this is the force, the direction of the displacement and the velocity are to the right, that are positive here. This one right here is going to, if I move it to the right, this is going to oppose it to the left. Okay, so with value k times x. This one here will have one like this, with value bx dot. And this, of course, is the mass. See, what's happening here is that you're going to say the application of Newton's law. It says the summation of the forces acting on a rigid body equals to the rate of change of momentum, like this. Or written in another way, this is m times x double dot, like that. So if this is true, we write the equation that says that F minus times x minus b times x dot is equal to mx double dot. Okay, so you see this is that summation here, and this is of course the rate of change of momentum. Now what I would advise you to do is not to reorganize the differential equation that you have in there, but rather I would like you to leave it like that, because it's, from the purposes of the block diagram, if you have it in summation form, it's actually better, it's easier. So I am going to say, okay, look at the summation point, we have this term, and this term is specified in a block like this. This is the F. Then you have, in here you have minus k times x, and in here you have minus b times x dot, and this equals to mx double dot. This step that I just did is very, very important, because you need to get this one right to get the structure going, because if you don't start here, then it's not going to work. So, or it's going to work, but maybe harder. So that's my recommendation here. Basically, what we have done is to transform the cursor. We have transformed this summation, this differential equation, into this little picture. So, but the picture needs to be completed. See here, we can say if you multiply this by 1 over m, you obtain x double dot. If you integrate this by 1 over s, you're going to have x dot. And to obtain plane x, you'll have to integrate it again. One over s. And then you have x. Okay. But you see, this is x dot, which suggests that if we take this and we multiply by b, we obtain this. Or if you take this and you multiply by k, you're going to obtain this. See? So this is my block diagram that we need to work in Simulink with. So what we do is, once we are ready, we have prepared this block diagram, we are able to translate now the block diagram that we have into the computer. The other approach used a bond graph and put it into the system. Now it's our turn to do this by using this approach. So what I would suggest is go into the Simulink in here. I'm gonna reduce the model small window so that we can actually work with Simulink. So let's start it on MATLAB in here. Where's MATLAB? Right here. Okay. So again, you see, we're going the same route. You realize now that both methods converge on the MATLAB side. One describes it through M files. You could also, using this method, you could enter the differential equations in M file the way we derive them and do integrations, but normally you go to Simulink. That's what you do. So, but we're gonna go is we say, okay, Simulink, yeah. We haven't gotten yet a response. You're still thinking about it. Once we get the Simulink running, we will open a new case, a new file, and transfers this block diagram into the simulink. That's what we want to do. Yeah, there it is. So what I would do is this. Just go and open a new one, a new case, because that's what that does. And go to where it says commonly used blocks. Everybody has its own style of doing things, and mine is I look at the block diagram that I have to do, and I realize I have these sources, I have these integrators, the scope, the summation point, and some gains. So what I would like to do is first let's just bring this ones. We're gonna need like 3 of these. This is that constant in here that I told you about. We need that one. We need these integrators, 2 of these. Then we need scope 1. Of course, you can always change this. Okay. There we go. Oh, we are I'm forgetting the summation point. That's a big deal. Very important. Right here. Because on the original graph, how many connections do we have? You see we have 4 of them. 3 inputs, 1 positive, 2 negative ones. So we need to do that. So we double click on this. So we have 1 positive and 2 negatives. Yeah, there you go. So it's a little better. Right. So in here this is the value of this is the force F, right? Just gonna do F in here. Connect this to here. This one's connect like this. This thing is 1 over m. These ones we need to flip. We do a control I for inversion. Like that. And this other one goes over here. And this other one goes to this one, see? Yeah. You see, I have finished now. Hopefully you were following also, but right now all we gotta do is to put the numbers. To put the to put See, MATLAB doesn't know these numbers. This one, also this is 1 over m. It doesn't know this one is being here, no, here. And this was k. Yeah. So what you need to do in this case is you could enter them as a prompt like f is equal to 10. How did I have it in there? B is what I have, B is equal to 3. Okay, we put k also. K is equal to 40. What else do we need? The mass, the spring, the mass also like 2. We don't. Yeah. And so if you go back to the Simulink picture right here, you could actually, this is the position, this is the, you could actually here say run, like this. Let's see if I'm lucky or not. It's working. And it actually did run, see? There's the response. So you have seen it both ways. We need to go more deep into this. And we need to review the concepts that we have for the generation of the state space form as well as the transfer function. So that's the other review that we need right now. But this one is, you could tell there is a big difference between the two methods. One, in the bond graph method, you let the computer write the equations. On this one, you are writing the equations. There's no getting around. If you don't get the equations, you don't get this block diagram either. Because the block diagram is a representation, a mathematical representation of the differential equations. Okay. So I hope this introduction has been helpful to look at how to do the same example both ways.